Hello, this is Mrs. Ross, and this is Module 7 Practice Set Problems. Let's go ahead and get started. Let's see. So we have our first problem. It says an airplane pilot nosedives and then pulls his, so we have we're given a mass of 455 kilograms upwards, forming a semicircle in the air. If the radius of his plane is meters and the plane's speed is a constant, what is the centripetal force? Okay. If you've done your notes, you'll know that the formula for centripetal force is m times v squared over r. Let me scooch this up a little bit. So we're just going to plug in what we've got. Times and I'm going to let you figure that out. When you turn it in, I'll check it. Multiply, divide. Next. This is a super long problem, but it's not long to do. So let's get down to the part where we're actually working the problem. So we are given, it says if such a ride has a radius of 5.1 meters and spins with the speed of how much centripetal acceleration? Okay, so another, another formula that we're given in the notes is that centripetal acceleration is equal to v squared over r. So we're just going to plug and chug. Plug that in over 5.1. I'll let you do that on your calculator. Next question. All right, let's keep going. So here we have a child attaches a, so this is going to be our radius. And we have to convert it to meters. So we're going to divide by 100 and get that. String to, okay, so then we have a mass of 15 grams, which we have to convert to kilograms. So we divide by 1,000. It says eventually the ball reaches this velocity. And unknown is maximum tension. So the force of tension is going to be equal to the force of the centripetal force. We know that the formula for centripetal force is mv squared over r, so we're going to plug in what we have. This is squared over radius, and you'll get an answer. 4. All right, so given we've got a car is traveling down a slippery road where the coefficient of friction is 0.22. What is the maximum speed of the car? So velocity. If the radius is 13.4 meters. Okay, so what we're going to do is we're going to say that the force of, not the force of gravity, my bad, the force of friction. We're going to say the force of friction is equal to the force centripetal because it's trying to stay on the curve. And we know that the force of friction is mu times mass times gravity. And we know that the centripetal force is mv squared over r. So mass is going to cancel, which is good because we don't have it. We do know that gravity is 9.8 since this is in meters. So we end up with mu times gravity is equal to v squared over r. And we are here, masses cancel. Solving for velocity. That's a V. My handwriting is literally awful. Okay, so this is going to be V squared is equal to R times mu times G. And we're going to plug that in. Once we multiply this, we're going to need to square root this and square root this to get our answer. Okay. Okay. Number 5. Okay. No, that's not number 5. Yeah, it is. It says a child watches a toy train moving around a circular track. He finds out the train makes 10 complete trips around the track every 1 minute. What's the frequency in the period? So we are given 10 trips in 1 minute. Okay, so normally the frequency is going to be in hertz, which is equal to 1 over seconds. So I'm going to say this is 10 trips in 60 seconds. So my frequency is 10 trips over 60 seconds, which is equal to, if I round it, that. Then I know that frequency is also equal to 1 over period, so 1 over, if I solve for frequency, I'm sorry, losing my mind. It's probably gone. If I solve for period, so that I can get, we have frequency, we need period, it's 1 over f. It's just a indirect. And I got 5.99 seconds or 6 seconds. That's fine. Okay, yes, I realize I answered that one. You're welcome. Okay, let's see. All right. Number 6, given we have 2 objects. M1 is 15 kilograms. M2 is 25 kilograms. They are 45 centimeters, which we have to convert to meters, so divide by 100 apart. We're looking for the gravitational force, so we're going to be using the gravitational constant. That's 6.67 times 10 to the negative 11. Unknown is force of gravity. Solution, we'll just start over here. The solution, the force of gravity is equal to the gravitational constant times mass 1 times mass 2 over r squared. So I'm going to kind of back this up over here. So this is 6.67 times 10 to the negative 11 times all right, so let's continue to plug in. So we have 15 times 25 all over 0.45 squared, and that's going to give you your answer. Number 7. Okay. How long does it take Saturn to make one orbit around the sun? So we are given the mass of the sun, the radius of Saturn, and then we're going to use our universal gravitation constant. We're looking for period, which is time. Okay. So we know that force centripetal equals force of gravity. Force centripetal is mv squared. Force of gravity is gm1 gm2 over r squared. So we're going to get rid of that and that, and one of those. So we have v squared is equal to g m2 over r, which is 6.67 times 10 to the negative 11 times 2 to the 30. Oh no. Well, I just noticed I used it doesn't matter. 1.4 times 10 to the 12th. Okay. And so you're going to get a velocity here. Once you get this, whatever you get here, you're going to need a square root so that you have velocity equals whatever that is. Okay. Once you have the velocity, we're going back to distance is equal to rate times time. Our distance is circumference. So we have 2 pi r, which is 2 times 3.14 times 1.4 times 10 to the 10. That's a 10. So distance is this. That's not right. Yeah, it is. Times 10 to the 12th. And then you're going to plug this back in. We need to find time. So this is our distance. This is our velocity is equal to our rate. And you're going to solve for time. Okay, let me know if you have any questions on that one. I think I'm going to go ahead and stop here and do 8, 9, and 10 on a separate one. Okay?